Oh boy, things just got harder. This is like f of x times g of x. And remember, if y equals f of x times g of x, then the derivative using the product rule is f dash of x times g of x plus f of x times g dash of x. So we've got our work cut out for us here. If we think of sine 8x as f of x and cosine 2x is g of x. All right, so y prime is, I can see the arguments of sine and cosine are not simply one variable. We've got an 8 times the x and a 2 times the x. So I'm going to use the chain rule. If this is f of x, our derivative is cosine of 8x times 8, there's that chain rule, times g of x, cosine of 2x, plus f of x, sine of 8x, times the derivative of g of x, which will be negative sine of 2x, chain it up, times 2. So y prime, well, let's clean it up. I've got 8 cosine 8x cosine 2x, negative times positive is negative 2 sine 8x sine 2x. All I did is I moved this 2 to the front there. There's not much I can do beyond that. Just leave it. Whoa, here we go. We've got a major problem here now, don't we? Well, if we said, let this thing equal u, if I said, let u equal sine of 8x minus 1, then my problem becomes y equals, this whole thing is u cubed. Y in terms of u, dy du is equal to 3u squared. All right? So if u is in terms of x here, then its derivative is du dx is equal to, the derivative of sine is cosine of whatevs 8x minus 1. The chain rule says times the derivative of whatever's in there is 8. So du dx is 8 cosine of 8x minus 1. So our chain rule, dy dx is equal to dy dx. Oh yeah, the chain rule just says du is our middleman or middlewoman. Dy dx is equal to dy du is 3 times u squared times du dx, which is this monster here, 8 cosine of 8x minus 1. And what is u? We said u was sine of 8x minus 1. So there is our first really, no kidding around, difficult problem. Now, 3 times 8 is 24. So we could write this as 24 sine of 8x minus 1 times cosine of 8x minus 1. That's all good too.